The title of today's session is Scan with Spider II, Reverse Engineer in SolidWorks. Before we start, for those of you who already is pretty fluent in reverse engineering, and especially for those who is using the specialized tools such as DesignX, during this session, we won't be telling you that the workflow with just Artec Studio and SolidWorks is way more efficient. No, DesignX and other specialized softwares are still unbeatable when it comes to reverse engineering. However, if you own only a scanner and you own a subscription for SolidWorks, and you're thinking about getting a specialized software, during this training session, I will tell you a bit what built-in tools in Artec Studio can be used to improve your reverse engineering workflow. Even though the session's name is, as you can see, Scan with Spider II, let me highlight several things that justify why exactly we chose Spider II for this particular application. So, as you know, especially those who work in manufacturing or prototyping, those of you know that there are basically two main domains where 3D scanners are used in this particular application. So I'm referring to quality control and to reverse engineering. So reverse engineering is a process of creation of a parametric model, also referred as CAD model, using a real physical part as a reference. And for this kind of application, accuracy of the scanner plays a less critical role compared to the scenario where 3D scanner is used for dimensional control. On the other hand, resolution and scanning and processing speed have higher priority, have upper hand here. Let's dig a bit into details. So here so today we will be using this WISE as a for the demonstration. And as you can see, I measured this distance. This distance equals 114.82 millimeters. So in case of dimensional control, this 114.82 millimeter defines whether the part is okay or not okay, because essentially the whole idea of dimensional control is to define whether a particular part is good or not good. So, as you may suggest, and this suggestion will be absolutely legit, that if we are not that sure about scanner's accuracy, this value can be, let's say, questionable. And if we are not entirely sure on the exact value, we can, so this basically can lead to two negative effects. The first one is when not okay part is considered as okay and sent to the customer and causes the problem at their place, or okay part is considered as not okay part. This is, well, the situation is a bit better, but still the second one leads to increased scrap cost, which also something that we opt to avoid. But if we are talking about reverse engineering, the scanner's accuracy, as I said, is less critical, because when we create a parametric model, we won't use this exact value anyway. That is because the part we are using is from the real world. And surely the real world parts, they have some difference from the ethanol, from the initial design. So irrespective of the scanner's error, the scanner's accuracy, we will put here manually 115 millimeters when we are modeling this part. We will talk about it a bit later. So why Spider 2? So for this particular application, Spider 2 has several major benefits. So the first one is zero, or okay, let's say almost the zero preparation. You don't need to place scanning targets on the object. You don't need to place these scanning targets on the base. You don't need to perform a recalibration. Uh, Basically, the same thing that you normally do with the laser scanners, which are using targets such as Artec point, for example. Another benefit is high data acquisition speed. So unlike laser scanners, where you need to pass the scanner over the same area over and over again to get a nice and dense point cloud, here, due to the structured light technology, you can scan faster, and there are one or maximum two passes are generally enough to get good and dense data. And superior resolution. This is very specific to Spider 2. This is especially useful when we are talking about, let's say, scanning for jewelry or scanning of something similar, where there are small geometry. There's small geometry. Yeah, so we have plenty of materials on our support center, so feel free to check it out. So if we are using the scanner for reverse engineering, the first step is to scan the object in order to obtain a mesh. Here, I would like to highlight several things that you need to consider and to know when you are scanning with a Spider 2. So there are several critical parameters that are absolutely worth your attention. So this is the main scanning interface of Artec Studio. So what you need to set up before you start scanning. So the point density, the upper slider. Point density, the default value is normal, which is something that we advise for the most of the applications. It provides ideal balance between the project size on the hard disk and the data density. However, if you are aiming to get the highest resolution, such as above mentioned jewelry applications, then feel free to increase it to full. In this case, the project size will be bigger because the data will be more dense, but at the price of increased resolution. On the other hand, if you are scanning something relatively big, like in terms of Spider 2, then feel free to decrease point density to reduced or even sparse, especially when you are scanning something relatively big, but something that doesn't have really small details that you need to capture. Yeah, in this case, the project size will be even less, but the level of detail will still be pretty impressive. Scanning speed, the next parameter. So the maximum scanning speed is 30 FPS. I prefer to keep it around 20 FPS, but again, it's purely the user's preference. If you are moving the scanner pretty fast, then feel free to increase the scanning speed. And on the other hand, if you are planning to scan slowly, then it is wiser to decrease scanning speed just to have more manageable data. And the geometry gain. This is something very specific to Artec Spider 2. We recommend to turn on overexposure indicator, and this slider will be active once you are scanning. So just set it up in a way that you don't see any overexposed areas. And overexposed areas, they're pretty easy to detect. So for example, you can see this little red area. It means that this area is overexposed. But again, it's in this particular case, it's nothing really horrible because well, you can see that absolute majority of the data is scanned pretty nice. If you see if you see lots of overexposed areas, then just decrease geometry gain. And yeah, make several scans in several positions in order to make the full visual representation of this particular model. So once the scanning is done, yeah, you will see several scans in the pretty random position. If you have several scans, let's say more than 2 scans, then it totally makes sense to align them in an automatic mode. Let me show it. Yeah, align, just click on auto and align. You can, of course, do manual alignment using point pairs. It's a user preference. There are people who prefer to do it manually. And for example, if we are talking about only 2 scans, sometimes it is debatable, but sometimes it can be faster than the auto alignment. But yeah, for example, in this particular project, I prefer to do it in auto alignment. Just yeah, it's better that Artec Studio works and not me. Right. So the alignment is done. And the next step is, I mean, it's still the part of the basic processing pipeline is the global registration. So feel free to use the default settings. The only thing that I would change for this particular object is to focus on geometry. Take into account that my object has a very good geometry and doesn't have lots of texture features. It makes total sense to use focus on geometry. And then you just, so once the global registration is done using the default settings, you just assess the results. The assessment can be done by basically 2 things. The first one is the error value. You can see that my error value is 0.1, which is pretty good. And then you go to, yeah, let me show it in the interface of Artec Studio. Yeah, you go to scan color and you go to, yeah, frame color. In the frame color mode, you just assess how well the data is intermixed one to another. If you don't see the big chunks of data detached from the main body, then it means that the global registration result is pretty okay. The next step is fusion. So tools, fusion. For Artec Spider II, we recommend Smart Fusion and Max Mesh Resolution. You use it according to the error value. So since the error value of my project is 0.1, I will be using 0.1. Check out, so choose the fill holes method that you would like to use. If you don't know, or if you're not sure what these values mean, feel free to check out one of our previous sessions where I was explaining the hole filling in detail. Yeah, and then you create a fusion. Once the fusion is created, you can see that there are several pieces of mesh here and there, like this one. They are caused mainly by the optical noise of the surrounding. It is not necessary to delete it manually. And another thing that worth your attention is that when you go to the scene settings and you choose wire over solid, you can actually see the mesh structure. And after some zoom ins, you can see that the object consists of really, really, really small polygons, small triangles. Of course, for reverse engineering, we don't need that detailed mesh. And it means that it's a high time to use the algorithm of mesh optimization. You go to mesh optimization of the 3D model, remove small objects, so all except largest. It means that so only the biggest object will remain and the rest of them will be deleted. Heal bad polygons, also worth checking. It can help with the healing non-manifold dangling crossing polygons. And mesh simplification. Here you can aim to a specific quantity of triangles. I'll cut it to almost 3 million. And yeah, let's see how it looks like. As you can see, all small parts of the mesh that we don't need, they are already gone. And mesh simplification is also executed. You see that there is absolutely no visual difference. But if we turn on the mesh structure back, now we have almost 3 million polygons. Yeah, you can see that this is before and this is after. You can see that the amount of polygons was decreased drastically. And also, if you have already executed mesh optimization one time, it does mean that you are limited to only one time. If you think that it's still a good idea to decrease the quantity of targets even more, you absolutely feel free to do it. In this case, you can just deactivate artifact healing because you have already executed the step before, and simplify the mesh again. Yeah. You can simplify even more depending on your particular needs. Now the mesh is basically ready, and this is basically the end of the standard processing of the processing pipeline. The next step, which I recommend to do, is to execute precise positioning. So what is precise positioning in a nutshell? Precise positioning is the tool which helps you to position your mesh body in a way that it looks more tech-savvy. So for example, you can see that if I play with the coordinate system, my scans, they are not aligned with anything. They have a pretty random position in space, and this is pretty okay. So once we have the mesh, what we can do. So precise positioning is the positioning which allows you to align faces of your mesh with the coordinate system. The problem is that the mesh doesn't have faces. So the CAD model has faces, mesh doesn't. For Artec Studio, so this flat surface is basically the same as like this hole, this corner, and so on and so forth. So what we need to do, we need to define the faces by fitting in primitives. So you choose the type of primitive, you choose the selection type. We have 3D brush, 2D brush, lasso. I prefer segment brush, segment selection type. Yeah, you can see that it automatically detects the planar face, and I fit plane here. And I will do the same here. Pick a plane. Now I have two faces, two planes. And before I align them accordingly, I would like to constrain them. Because, of course, you know that ZOX is perpendicular to XOY, but these two are not perpendicular one to another. So I need to assign the perpendicularity. How to do that? Just so when you are in Construct tab, Construct tab, right click perpendicular to this one, refit. Yeah. Now you can see that after refitting, this plane is more perpendicular, and this perfectly okay because this base is like in the real object is not ideally 90 degrees to the base. And now we can go to the precise positioning. So precise positioning, you go to editor, precise positioning, and so you can see that the object that I'm working with is already positioned pretty good, but yeah, let me do it once again. So plane 23 is this one, plane 24 this one. I will align plane 24 with XOY. You can invert direction if you don't like it, the initial one. And plane 23, something with probably ZOX. Yep. Now you can see that uh, plane 23, plane 24. Yeah, sorry for that. I had some excessive work on the primitive fitting here. Yeah, here you can see which plane is aligned with which like plane of the coordinate system. Right, let me back. And this is how you do the precise positioning. So the next step is cutting the sections. So sections are uh, the section is a very good tool when it comes to reverse engineering. Surely, those of you who work extensively with SolidWorks, they know that this tool actually exists in SolidWorks. It is called slicing. And this tool was developed by SolidWorks, especially for this kind of purpose. You can import the low polygonal model to the SolidWorks, and you can cut the sections there. Uh, uh, Generally, SolidWorks, yeah, it is capable, but those of you who know SolidWorks, you also know that uh, SolidWorks is not exactly very well adjusted to the meshes, especially with those which contain a high amount of polygons, such as any object scanned with the Artec Spider II. So if I import this kind of object into SolidWorks, it will be pretty hard for SolidWorks to process it. You will experience significant lags, and yeah, you may even end up just having a crash on SolidWorks, and that's it. Uh, so you can, yeah, as I said, you can use this uh, slicing tool, but since Artec Studio, the core operation of Artec Studio is working with scanned data and with meshes, um, getting the right section uh, is easier in Artec Studio. And why do you need sections? Sections give you basically, a section gives you a silhouette or a contour, which you will be using as a reference for your future sketching. So what you can do, how you can create sections. So in order to do that, you need to have a fit in primitive, fit in plane, more precisely. You go to measures, sections, and volume. And here, amongst all the options, you click on use constructed planes. And voila, here how it works. So um, you're not constrained by the position of your plane. You can easily adjust the position of the cutting plane because, well, generally your objective here is to adjust the cutting plane in a way where all the necessary data is visible on this contour. You can also modify the angle, but it is not something, say, I personally like to do because normally I just find something that looks like a plane on the object. I fit in the plane, and then I just create one or several sections. Yeah, don't forget to click on calculate. You can unmark the fusion, and voila, here is your section. If you're okay with this section, don't forget to save it. And yeah, all the sections, they are stored here in measures. So you, at any moment you go to measures, you have everything here. uh, that is basically how you create it. There's another small tip um, when it comes to section cutting. Sometimes, and this is especially useful when you are working with bigger objects, like for example, this front panel of the Willis truck that we scanned with Artec Leo. Sometimes, due to non-flat geometry of the part, it is quite hard to fit in to fit a plane in a way that it shows you all the features that you would like to have for your future reference. So, for example, you can see that I fitted in a plane here, and the problem is that the plane is ideally flat, and the old front panel of this truck is unfortunately not, which leads to something like that. So as you can see, this section is not really useful. So what you can do, uh, in the same way as it works in slicing tool, here you have the quantity of planes. And this tool has a very, very good usage for this particular application. Uh, and for example, here I created 5 planes with a 2 mm spacing. And not only I get this beautiful picture of a section that looks like a tiger or like a zebra camouflage, but also the main reason for this section is to give me all the references that I would like to get. And well, let's check this one. So I have all these parts of the radiator grille. I have the spaces for lights. And like on the other hand, here I have almost nothing. Yeah. Um, if you created several cutting planes, they are still saved as one entity, and they will be it will be possible to send it to SolidWorks using it will be possible to send it to SolidWorks in a way that all the planes, all the cutting plates, all the contours, they will be within the same plane. We'll talk about it later. So export to SolidWorks. Here we basically have 2 main approaches. The first one is to, like, when you go to measures, you have a button which is called Export to SolidWorks, and as the name implies, this button actually sends the data to SolidWorks. So what you need to do, you need to check what entities you want to send and export to SolidWorks. How it will look like in SolidWorks. As you can see, this is that is like the section, but take a look at the object list. You can see that this object, so even though this is like the one section, actually there are probably several, maybe two or three sections, they are visualized as the bunch of objects in the object list. So if you are okay with this kind of visualization, there's absolutely no problem. There are people who do that. You just create a new sketch and you use this silhouette as a referencing contour for your further sketching. Another way is to use the export button. And in export button, you just need to save it as DXF file. You save it into a designated folder, and then you just open it in SolidWorks. So you define the plane where you want to project this DXF, import, you find the right section. Yeah, to the sketch. Don't forget to modify the units of imported data. So yeah, in this case, it should be millimeters. And you here see the preview of the contour that you are about to export. You can modify it here, but honestly, it is easier to get the necessary positioning of the contour in Artec Studio. So I almost never change this positioning in this window. And you click on Finish. And here we go. Here is the same contour, but now it is visualized as a sketch, as a one entity. And yeah, here we go. And then you do usual sketching using this silhouette. Maybe anticipating your questions or the question of someone else. Sketching is still necessary. You still need to do sketching for the yeah, you still need to do the sketching for reverse engineering process. The section can give you a good referencing for the positions, the size, and so on and so forth. Of course, now we won't be, watching the full video of how I modeled this part because, well, I strongly believe that most of you know already how to work in SolidWorks. It's an absolutely amazing tool. If you have some doubts in your skills, feel free to go to YouTube, LinkedIn. There are plenty of very good materials. What I would like to pay your attention to is what are the specifics of working with the sections imported from Artec Studio. So now you can see I created a line, but you can see that the line is black and the beginning of the line is also black. It means that the beginning of the line is constrained. But how it is constrained, if I didn't constrain it whatsoever? Take a closer look to the section and you see that this contour is not like one spline. The contour represents sometimes several thousands, very, very small lines. It is a polyline, they are connected one to another. And when you are clicking on the contour when you start your line, the SolidWorks will automatically make the SolidWorks will automatically create a constraint on a particular point. You can see that this point is constrained, and well, to be honest, I mean, absolutely no problem with that. If you created a line in this way, you just manually delete this constraint, and the line is back to being undefined. You can modify the length, you can modify the positioning, and so on and so forth. Yeah, that is something that is, let's say, the special thing about Artec Studio sections is that they consist of small lines. The lines are connected one to another with dots. And if you click on a silhouette on the section when you are sketching, you will get an automatic constraint, which is pretty easy to delete. What else? So yeah, here I'm doing the same. What else? How you can do? Of course, it is not necessary to start your line right on the contour. You can create an arbitrary line in some free space, and then just manually drag it in a way that it corresponds to the contour. In this case, you won't have any undesired constraints. Yeah, and this is another way of working with the sections in SolidWorks. So this applies to lines. Uh, yeah, you do the usual sketching using all the tools that you find useful. At some point, when you have enough geometry and you don't need the help of the sketch anymore, you can easily easily hide this section. And if you imported the section as a DXF file, it will be pretty easy to do because you will need to hide only one entity. And yeah, you just continue working with your sketch. The same applies all the things that apply to lines. The same things apply also to circles, to rectangles, to splines, and what I personally find especially useful, uh, positions of the bores and position of the um, uh, let's say more complex geometry such as slots. Uh, uh, they are also easier to do with the section turned on. Yeah, and here is exactly what I told you in the beginning of the webinar. So if I want to measure an entity, of course, the value won't be, let's say, something 0.00, because it's the real object from the real world. And this is what you normally do. You take the measurement using smart measurement, and you define the value here. And you define it in a way that it could actually make sense from the production and the prototyping point of view. So instead of 70.09, you get just 70, and the same center line. yeah, when you create center lines, it's actually easier to create center lines without visualization of the section, because yeah, in this case you can avoid unnecessary constraining to the section. And the same applies to all other objects, as I said, as rectangles. So you place the rectangle more or less according to the section, and you start dimensioning it. Of course, keeping in mind that dimensions have to be they have to make sense. So for example, here 19.50 instead of 19.48, because I mean, let's be honest, this part, there's no way that this part should be manufactured with like 19.49 and plus some crazy tolerance like 0.002, right? So yeah, here we will be using the 16 instead of 16.02. And yeah, this is essentially how you sketch in SolidWorks using sections from the Artec Studio. Well, as you can see, if you have a section with lots of geometry, it is indeed very wise to create a section and use it as a reference. But sometimes you can use built-in measurement tools when we are talking about, let's say, less complex shapes. For example, once I extruded the sketch, I will need to cut off this internal part. Surely I can create a section, but let's be honest, this cut extrude feature is in fact a rectangle which has 2 or 3 dimensions. So sometimes it is easier to use the same approach. So you create several primitives, several planes, and you just take measurements from the interface of Artec Studio. How to do that? It is pretty simple. And here I would like to pay attention to one thing that is, let's say, special to Artec Studio interface. So if I want to know the distance, let's say the depth of this extrusion thing, I need to measure the distance between this area and this area. So as you can see, I have already placed the plane. So what I can do, I can create another plane here and make plane-to-plane measurement, or I can do a point-to-plane measurement. But when you do that, please be mindful and please pay attention to the order of the point placement, because the correct order is that you place the first point on the mesh, and then you just click on the plane. You can see that this line is a true distance. And how can I know that? Because here I have small sign of perpendicularity. It means that this line is perpendicular to the plane. And even though the border, let's say the limit of my plane is here, it is not important, because if I want to take the true distance, Artec Studio will automatically continue the plane up until the meeting point with the perpendicular. Why it is important to place the first point here and not vice versa? Let's do it vice versa. Let me put the first point on the plane and another one in the mesh. You can see that this is the distance between 2 random points, and surely it doesn't make absolutely, so it makes absolutely 0 sense. So yeah, that's why the order is important in this particular case. And going back to the features, yeah, as I said, if we are talking about fairly simple features, sometimes it's easier to just take 2 or 3 measurements in Artec Studio and use them in the interface of SolidWorks. So I just create the rectangle, which is 20 millimeters offset from this face, which is 28 millimeters length, and 21 millimeters the offset from the other side. So yeah, what I'm trying to say is that you can use sketches, you can use built-in measurement tools. Yeah, it's just up to you. Sometimes it's faster to get measurements from the Artec Studio, but of course, if we're talking about um, objects which are pretty feature-rich, then yeah, sections will give you way better referencing. And final touch. The final touch is, well, as the most of you know, the final touch in any CAD design is to add fillet, chamfers, and sometimes if we are talking about the casting part, you can suggest that sometimes some draft angles also should be used. And as you can guess, this is exactly the part which was done from using the casting method. Um, so what you can do, once the part is almost ready, you can put it into Artec Studio. This is my part. As you can see, no, so I mean, it looks pretty rough because it doesn't have any chamfers fillets whatsoever. Uh, you just align the CAD with the mesh, and what you need to do, here we have on the bottom panel, we have the button which is called Deviation Analysis, and let's execute. Not bad. Yeah, maybe it's because I designed this CAD model. Maybe that's why I think it's not bad, but okay. I think it's not bad, but you can see that there are, even though that there are some areas that are pretty fit, like these green areas here and here, you can see that this area is orange, this area too, and you can see that the actual difference between the CAD model and the mesh is 1 millimeter. And surely you can suggest due to the difference, so seeing the difference between the bottom and the top of the part, we can suggest that the difference is caused by the draft angle, which is not yet implemented into our CAD design. So what you can do, of course, no question to that, you can do all the final touches in the SolidWorks interface, but we have some tools here, and I will show them to you. Okay, so here's my part, and you can see that if I check the mesh, some parts are not accessible, but if I marked CAD, you can see that all the tools are accessible. So what I will do, I'll find the draft angle here. First, I will click on the base plane, then on the face that I would like to modify. Let's put 2 degrees, apply. Yeah. We can do the same with the rest of them. This one. Yeah, now our part has draft angles. Let's do, yeah, you can see now that it is now way more aligned with the mesh. Let's take a quick analysis, and you can see that now it looks way better than it used to be, right? So before we had even some red areas. Now everything is green or greenish, let's say. Yeah, and that's how it works. And of course, if we are basically done with the checkout design, so initially the idea of this deviation check is to check the main features, like that all the slots are corresponding to the mesh, that all bores and other features correspond to the actual physical part. If we are sure that everything's okay with our main design, yeah, as said, we can add final touches here. Here we have chamfer, here we have fillet. Let me click here, here. Yeah, probably not here. That was a bad idea. Bad idea. So it's 5 mm. Apply. Yeah, and let's apply more modest fillets. So as you can see, take into account that this is the same contour, the fillet has been applied to all of it. And that is how you, that is how you add final touches on your model. Again, it doesn't, of course, substitute the full design pipeline in SolidWorks, but for some, let's say, uh, for finalizing the part, sometimes it is more convenient to do it in the interface of Artec Studio, mostly because in Artec Studio, you have way better visualization of CAD and mesh. So, some conclusions. As I have already mentioned in the beginning of this session, there are indeed pretty amazing tools, such as the software from our partners from Hexagon Solutions. I'm referring to DesignX, a great tool when it comes to reverse engineering using the meshes, using the scan data in general. But now I have explained you how you can do the reverse engineering in SolidWorks using built-in tools of Artec Studio without DesignX. So you may ask yourself a question like whether you need to invest in DesignX, and the answer is, well, the answer is pretty logic, and it depends on your particular situation. So scenario A, if we are talking about strategic software investment, in this scenario A, when you have high volume, or like if you're an Artec partner, if your customer has a financial flexibility, let's say. If reverse engineering is a core and frequent business operation, or as I said, the client just has the financial means for investing in the specific software, it is something that we can surely recommend. So DesignX, also there are other sometimes budget-friendly solutions like Quick Surface and Mesh to Surface, and the benefits are more than clear. So significant time savings, automated feature recognition, and superior handling of complex organic and freeform shapes. If you are not yet sure about the capabilities of DesignX, just just search it on YouTube. There are amazing video tutorials done by Hexagon Manufacturing. Yeah, they are absolutely great, and I highly recommend seeing them before you make the decision whether to invest in the specific software or not. But if reverse engineered projects are occasioned and the budget is strictly limited to the scanner and the SolidWorks subscription, and there is no urgent need to buy expensive additional software, then the workflow that I have just demonstrated can generally give you good results. Of course, you will need to invest more time compared to more automated solutions, but it is something like a cost-effective sweet spot that delivers high-quality results through smart use of existing tools. Existing tools meaning the built-in tools in Artec Studio and vast and amazing capabilities of SolidWorks. So the question whether to invest in design in the specific software or not, it's actually like more philosophical question about automation in general. So when you like in your business model, if you have reached your maximum capacity and you want to be more effective, you want to, and by being more effective, you will be able to get more orders and in a like as a result to make more money, then of course you can consider this. You can consider buying the specific software as a good investment. In this case, you will be able to even calculate the return of investment parameters. And yeah, so it works as with any automation, like in general, irrespectively of software or hardware, so on and so forth. Yeah, but if, as I said, if the budget is limited, if you or your customer are not yet decided, let's say, to whether to invest in a specified software or not, but you have already needs to use the scanners for your reverse engineering process, then the path that I just explained can be a good starting point because I mean, using the measurements in Artec Studio and using sections and using them in SolidWorks can still deliver a result. And you accelerate when ready. So when you feel that you, with this workflow, you have reached your limit, then yeah, that's high time for automation.